So as we can see, Liquibase diff, this is a compare command to compare the local database with the integration database. For example, when I compare, usually I get the result as defining as we can see, like for example, what are the missing columns, what unexpected columns, and the changed columns. Like for example, if the result has including some, if there is no change or missing, then you will see the result is none. If there is a change, you will not see anything, and you will see the description of the change. And as we can see, let me show you an example. So with the diff command, this will display in 3 items, as I explained before: missing, unexpected, and changed, for several items. Let's say, for example, tables. So if there is no missing or unexpected or a change, it will be none. But if there is a change, you will not find anything, and we will find the description of the details. And this will be columns, foreign keys, indexes, primary keys, tables, unique constraint, views, catalogs, and schemas and sequences. As example, as you can see, missing columns, there is no any missing columns, which mean that I don't have anything in the target, in the integration database, which is not, exist on my local database. But unexpected columns, which mean that I have some columns in my local database as a developer 1 or developer 2, which is not exist in the source or the integration database. And here's the changed columns. If I run Liquibase status, for example, this will show me here the details of the change logs that inside the change set inside my change log, which is not committed yet or applied to my local or target database. We will see this command in the demo. This is an example, for example, when we run Liquibase status. Just to run here. Okay, so, and here, this is if I want to run a Liquibase diff change log, which means that to generate the change log based on the schema compare between the local database and the integration database. So this will generate the change log file. So let's start with the first demo. So the first demo is how to install and configure Liquibase. So as you can see, I just go to download Liquibase. And in my demo, I need the Snowflake driver. So I will install the jar driver for GDBC driver, the latest version, which is Azure drive file. And also I need the extension for Liquibase for Snowflake. This is an extension so Liquibase can communicate with Snowflake. Here, and just installing, this is the extension and the GDBC driver, and here the MSI or the installation. So I just need to install, which will be direct installation, very straightforward. And then I just need to take the 2 drivers or the jar drivers and put them here in the library inside the Liquibase folder. This is for H2 database that we will use also in the second demo. So once I put the drivers, then I just need to update the environment variables. By default, it will update the path for the Liquibase. This is for my environment variable as a profile, as a user. But for me, I will use several users on the same machine, so I will update the system environment variable as well, because in the third demo, we will use a dev1 and dev2 scenario, and then which required Liquibase to be recognized on the system, not on my user profile as Muhammad Radwan. And now just to start here, just to show you the developer here. This is the dev1 and here is the dev2. Okay, so now I will run git bash and just type Liquibase. Once this display, it means that it is installed correctly. I can also run that from the command line, either command line or git bash. It's up to you. For me, I would prefer git bash. It's up to you. Okay, let's talk about the second demo. So in the second demo, we will connect with the local database with H2. So just to remind you, remember that there is here, this is an example that just come with Liquibase after the installation. So I will just copy them, just put them in an empty directory. It's called try Liquibase. And as you can see, this example is using SQL and XML as a language for how we track the changes. I will use the SQL example, so I will delete the XML, I don't need them. And I will just copy these files outside and delete the SQL directory. So this is an example of the blank changelog, and just explaining how the structure of the change set inside the file. As we can see, the name and the unique ID for the sequence. And here, this is the sample changelog, which include, as we can see here, 3 changes. Let's change my name here. So let's say Muhammad Radwan, because this will be the change set number 1, creating the first table, and here creating the second table. Leave this as it is. So as we can see, I have 3 change sets by this table, and here to alter table person by adding a new column, which is country. And this is the Liquibase property file, so which will using H2 database, and here the name of the changelog file, and dot the type of the database, dot the language. And we can see that Liquibase support different databases actually. So for example, MySQL database, Maria database, many databases, and one of them is H2, which is in-memory databases. And of course, Snowflake as well, that we will be using in the next demo. So this is for H2 database. So as we can see, dot the database type with H2 and dot the SQL. And here, this is the target database or my local database as a developer. And this is the JDBC driver for the URL of the database. Let me now here just navigate to show you the driver. So in the library, we have the H2 jar driver, which working with the JDBC driver for H2. And this is the username and password for the database. And this is the source database or the integration database. And I'm using that with the reference URL. And it is the same username and password. Of course, this is just an example. Okay, I will run the command line. So to start H2 database. So there is a patch coming with a sample called start h2. So I will just run this patch. By running this patch, it will just start the database h2 in memory. So this is a dev environment. Just here try to open another session with the integration environment. So this is the integration environment. And this is the dev environment. Okay, so we have two databases, as you can see, the local or target and the source or the integration. Okay, now I will run git bash and start navigating to my changelog, which exists on the C try Liquibase. And then I will start by run Liquibase status. So this will display what inside my changelog which is not committed or applied to my local database. So as we can see, I have 3 changes not applied to my local database yet, which is, just to remind you, this is the 3 changes, 1 and 2, 3. So if we go for the dev database, we can see it doesn't include anything. And of course, if I use Verpus, for example, this will display details of this change set, like the name of the developer, the number of the change set. So as we can see here, with more details about the changes. So now if I run Liquibase update, this will take all the changes that is not applied yet and update my target or local database. So for now, if I refresh the database or the session, just let's connect to the integration and the developer database. So the integration is empty. And the dev or the local, just to make sure it's another session. So as we can see now, I deploy the changes to, this is the integration, which is empty, but my local database or target database have the changes, which has company table and person table. So we have also a very important table called database changelog. So if I executed that, this is where the tables that track all the applied change sets. And we can see I have 3 change set applied already, with of course the ID of the change set. Okay, so now if I run status again, it will show me that it's up to date because all my changes in the changelog has already applied in my local database. But again, integration database doesn't include that. So let's say now Liquibase diff. This is to make a schema compare between the local database and the integration database. So as we can see that it shows me here all of the item as unexpected because this is from the integration to the dev. If I make the comparison in the opposite, it will be missing. So just be careful about the difference between missing and unexpected. So missing, it means that it is part of the integration database that is not in your local database. Unexpected, it means that is part of your local database that is not part of the integration database. Okay, so all of the item is unexpected because this only on my local database. Just close the command line so I can restart the database, because this is a memory database, so it will be just like run again. So I will start H2 again, and let's do the opposite, which is target database and make schema compare with a target data with a source database that has a schema and a target that has no schema. Okay, just open another instance so we can open the div and the integration. This is the integration database. Okay, so here just to refresh. Okay, so I will get back to Liquibase, and then here I will just update. But instead of updating, which will use the Liquibase properties with the target database, I will override this value with the source or the integration database. Of course, in reality, I should not do that. If you remember the best practice and the workflow, I should update the integration database only from the CI/CD. But again, here, just to show you what we are going to do. So here I will update the integration database from the command line. So this will override the target database with the integration database and update the changelog to the integration database. Again, so just the integration. So as we can see, the integration has all the tables now. If I go for the dev environment, we can see that dev environment doesn't include the schema changes because I only updated the integration database. So now if I make the comparison, which will compare the target, which is the local, to the source, now we will see all the changes as missing because it exists on, of course, here this is the change log, the status, and here the diff schema. All of the changes, we will see them as missing because it exists on the source and the integration database, but it does not exist on my local database. So I'm missing them, which means that I need to take these changes from the integration database into my local database. So missing table, missing columns, missing constraint, and so on. Okay. Let's now, for example, just show you something else. If I delete this changelog file, and let's get back to Liquibase, here the command line get bash, and I will take this diff and with the changelog, which means that make this comparison and generate the changelog for me, which bring all these changes from the target as the source database or the integration database into my local database. As you can see, this will generate the change set with unique ID and sequence. Okay, so now if I say just update, so this will execute the changelog, which has two changes to the developer database. So if I refresh now developer, I will find company and person tables. And of course, in the changelog, we can see that I have only two changes which exist in the changelog file. Okay, so let's get back to so talking about Snowflake. So for those that they don't know Snowflake, just a very high level, Snowflake is a cloud-based data storage and analytics services, generally termed as a data warehouse as a service, or DaaS. So it allows corporate users to store and analyze data using cloud-based hardware and software. So it is just a cloud solution for database with a business intelligence and data warehouse. Okay, so now when we're talking about Snowflake objects, there is several types of objects. So what we usually say, like, or it's account level objects like user, RBAC or role-based access control, database, all of this. And there is also a schema level objects, which is table, views, and so on. So the recommendation is to have a separation between how you manage the account level objects and how you manage the schema level objects. So for example, the account level object can be managed using infrastructure as code like Terraform, which configure also with CI/CD pipeline, and manage the schema level object with proper DCM or database configuration management, to manage the schema changes and so on. Okay, let's go for the last demo, which will be a long demo. Okay, so in this demo, I just remind you about, because we will using Snowflake, so I must have the Snowflake extension for Liquibase and the driver, which I already have here in the library. And then I will navigate to the Snowflake here. This is the UI of Snowflake, and this is a Snowflake sample data which come with the Snowflake account. It's free for 30 days. You can create your own Snowflake account on the cloud for 30 days. And here, the Snowflake database with several schema. Let me show you, for example, some of the sample data. So here I will just create 3 tables: Dev1, Dev2, and server integration. So if I refresh, we can see that I have now the 3 databases. I create 3 databases with default schema, which is the public. And here I create Azure DevOps project with the repository, and I copy this, which is empty clone. And now I will navigate to user. As you can see, I have Dev1, Dev2. So I will navigate to Dev1 repos. Here we will work with developer1. So first we will run git bash as a developer1. So this is Dev1. And enter the password for developer1. So now git bash running as a dev1. So as we can see, just adjust the spaces. So here I will just navigate to repo for developer1 users and go for dev1 and repos. Just let's clear the screen, and then I will just use empty repo, which is I just created. So here we can see that it just clones this remote repo in my local Git repo, which is an empty repo. Okay, then I will just, I have Liquibase property file. So I will just add this Liquibase property file here. And let's look at this property file. So we can see that here I just have this target database or my local database, and this will be the dev1 database, and the schema is public. And here it will work with server integration database as an integration database. This is the source or the integration database. And this is the type of the database, which is Snowflake, and the language, which is SQL. But I would like to take the sample database to generate the changelog for the sample database. So I will just comment this integration database and make the comparison to happen between my local database and the sample database of Snowflake. So here I will just navigate to directory and then run Liquibase status. Of course, I don't have a changelog, so it will give me that the changelog does not exist. So I will just run Liquibase and make diff. So this will show me that all the diff comparison between the sample database of Snowflake and my empty dev1 database. So all the changes will be as missing changes. So what I just need is to make a changelog with all these changes so I can deploy them to my dev1 database. So now with a changelog, this will generate, we will see that in the top, that this will generate the file. As you can see, the file generated. So if now I open the file, we can see that it just generates a chain set for each object inside and with unique ID. So I have 25 chain set. So now I have the chain set. So I will now just uncomment the integration database and commit the Snowflake sample database, because I was just using that so I can pull the schema. Okay, so now I have the integration database as the integration that I already declared before, which is empty now. Okay, so now if I run Liquibase status, this will show me the summary of the status, which will 25 change set in my local change set log, which is not applied yet to my local database. If I say with verbose, so we will see that this is the details of the change log. So now if I navigate to Snowflake, let's look at dev1 database. We can see the public data schema is empty. Now if I navigate back here and start run Liquibase update, so now this will take all the change sets in my change log and apply them to my local database, which is dev1 in this case. Now it's complete. So if I refresh now, we can see now I have all the tables and the schema. So now I applied the changes to dev1 environment, but dev2, of course, it doesn't include anything, and server integration, it doesn't include anything because this is only on dev1. Okay, so here, as we can see now, I am still empty repo because all this changes in my local repo, not in the remote repo. So what I will do is just create a get ignore, because Liquibase property should not be part of the source control. So I will create a get ignore to ignore this file, to commit this file in the source control, and name my file as get ignore dot get ignore. So this will create the get ignore file, which configured to ignore Liquibase properties file. And just to show you, if I just delete that, to show you what will happen for people that they don't know get ignore or they just confused. If I say now get status, we can see that there is 3 changes not staged, and let's add get ignore or staged get ignore. So now if I say get status, we can see that I have 1 file stage, which is get ignore, but 2 files not staged. And if I commit the get ignore and adding a comment add get ignore file, get status. So as we can see, Liquibase property is still, in untracked. So if I put here the Liquibase property in the get ignore and save that, so what will this impact is, if I say status, we will see that now I have only 1 file on stage. Of course, the second file changed, which is get ignore. So now I added both the get ignore and the changelog, but of course now I ignore Liquibase properties file. So let's now commit the changelog by just add a comment adding a changelog. So now I committed the changelog to my local repo, but remember this is still in the local repo, not in the remote. So let's just to confirm that there is no code here. So just to get push, so I can push all the branches to the remote repo from the local repo to the remote repo. So if I refresh now, we can see that now I have the code in the remote repo, and this is the changelog including all the change set from dev1. And here I configure a pipeline, Azure pipeline. And as we can see, if I click edit, this is just to update Snowflake, just runs Liquibase with a username and password, and just to give the URL of the integration database and the public schema, and here the changelog file. And here I put in the variable the username, which is my user account for Snowflake, and here is the password as a secret. So now, as we can see, the server integration database is still empty. So what I just need is just to confirm it is still empty. So what I will just need is to just run this pipeline by just queue a pipeline, which will get all the changes in the version control and apply that changes in the integration database in the Snowflake. So this is just waiting for the agent. Now it's downloaded the source control and the build agent. Now it's updating Snowflake. We can see that the Liquibase is running now on the build agent. And if we get back to the update Snowflake task, we can see that it's executed successfully. So now if I return back to Snowflake for the integration database, let's refresh. We can see that I have all the data, the schema and the tables of my database, which come from the version control. So integration database must always update it from CI/CD and version control. You never update integration database directly. You're always doing that with your local or target database, but not with the source or the integration database. So, and this is a change log where it tracks all the changes and the sequence of them. Okay, this is a server, but as you remember, Dev2 still not have this on his local database. So let's now run git bash as developer2 and see how the developer2 will work. So if I run git bash as dev2, so now git bash running as a developer2. And let's navigate to the developer2 directory and repos. And here it will be the same, just from git bash navigate to this directory. And I will do the same, just git clone, and let's clone the remote repo. So I will just copy that URL of this remote repo. So this will clone the remote repo on my local machine as a dev2. But of course, this is not an empty repo. This is already with a change log. But as you can see, there is no Liquibase properties because I already ignored that because it's not part of that. This is why every developer should configure a Liquibase property file on his machine, and also Liquibase support environment variable for the commercial version. So now if I navigate to the DCM, I will just copy the Liquibase property from dev1. Of course, he should just create this, and we will change the local database from dev1 to dev2 because this is the dev2 configuration. But of course, it is the same integration database. And now if I start access DCM Snowflake, and then let's clear that. Now, if I run status, you can see it's up to date because Liquibase properties is ignore file. So if I run now Liquibase status, we can see that all the changes will show as not applied, which is 25 changes. All of them is not yet in the dev2 local database. So now, as we can see, this is a dev2 and his public schema and database is empty. So what he will just do, again, he just run Liquibase update, which will take applying all the changes in the change log to his local database. So now if I refresh, so we can see now dev2 has the schema of the database. And of course, if I look at the change log, we can see all the executed sequence of the change sets. Okay. So now let's think of something different, which is how about if developer 1 would like to develop a new feature? So in this case, developer 1 will create a branch. Let's say feature 1 branch. And then check out this branch. So if we navigate to developer 1, so this is a developer 1 repo. So let's copy the last chain set and paste it again. And just to change the table, of course, this will be 26, the sequence. And here just add a new table. Let's say dev1 table. So that's it. So now this is developer 2 and this is developer 1. So as you can see, if I run Liquibase status, it will show me that I have only one changes, which is not applied yet to my local database. And we can see that this is the dev chain set number 26. So again, I do that, I update my local database, everything is, I must compare my local and target database with the integration database always to make sure if I missed anything, and which seems I don't have any changes in the integration, which is not exist in my local. I just have some changes which I didn't commit yet. So let's update first. So here, this will apply the 26, the chain set number 26 to my local database. So if I come back now, as we can see here, let's refresh. So I can see here, as you can see, dev1 table now is in dev1 machine. But if we look at here, we only have a master branch. We don't have feature 1 branch here in the remote because all of that here in the local. So what I just need is first is git push. But again, this will even push the feature branch without the last commit because I didn't commit yet the code. So if I look here, we can see now I have feature 1, but this not include the last changes. So now I just git status. We can see that I have the change log modified because I add one table, and here I will just add it and commit that, adding new table, which is dev1 table. This is just a comment. Then git push all branches to push the feature 1 to the remote repo. Now if I refresh now here with the feature 1 branch, and as we can see now I have dev1 table, but again, and this is the comment, but again this is the feature 1, this is not the master. So the master, it doesn't include the last table. So what I will usually need to do is to create a pull request so I can merge these changes from the feature, and here I can make a compare between the change log in the feature and the master, which show me here the changes, and then here I can add other reviewers and create the pull request. And of course, once I approve by the reviewers and complete the merge, this will merge the feature 1 to the master branch. So now if I go to the master branch and look at the history, we can see the merge, and we can see also here, this is just as a diff. But here we can see at the end that in the master branch, I have now dev1 table. But of course, the integration database is not included yet, the dev1, because I didn't run the CI/CD. So I don't have the dev1 table yet. But as we explained, integration database always updated from the pipeline. So what I just need to do is to run the pipeline. So this will just run the pipeline. Update the Snowflake based on the latest change in the master branch. If I come here, it was successfully. Let's get to the integration database. So now I can see here dev1 table deployed to integration database. So this is how we can see the life cycle of deploying a change as a developer one develop new feature, and how he usually follow that. For developer two, he doesn't include that. So if he make a diff, then he will understand that there is a missing table, which is dev1 table, which means that there is a change in the master branch which is not included in his branch if he has a branch. So, and this is the missing columns. So what he just need is to just pull, because this is a master, he still has the master. So what he just needs to do is just assembly change, not including that. So if I open, because this is assembly change, it doesn't include the latest table. So what he will just need is just to pull the latest from the remote repo, git pull, and this will pull all the changes. So if I open the assembly change now, refresh, we can see now at the end I have dev1 table. This is for developer 2, and then he can run Liquibase update, which will update his local database with the new change from developer 1 based on the pooling or the pool from the remote repo. That's it. So that's it. Any questions? Let me look at if there is any question on okay, I think there is no question even here.